All right, guys, let's go on to lesson 28. Just a few things to keep in mind. And the best way to remember something is either to memorize it or to write it down. So let's just see a couple of facts. If you have, this is a radius, okay? How do I know this is a radius? Because it goes from the center of the circle to one end of the circle. Oh, okay. So it intersects the circle at some point. So when a radius is perpendicular to a chord is a line segment, okay, that has two endpoints on the circle. All right. When it's perpendicular, it divides the segment into two congruent segments. Oh, that's nice to know. Of course it is. Another important fact is the following. If two chords are congruent, then they are equidistant from the center of the circle. That means that they are at the same distance from the center. If this distance here is 5, then this one is also 5. All right, what else? Well, here it says, if two chords are congruent, then the arcs, this is an arc. Look, fellows, this is an arc. And this is another arc right here. Yep, it's difficult to draw it. So the two arcs are also congruent. So if these two chords are congruent, the arcs that they intersect are also congruent. Cool. Right here. Two segments being parallel. If two chords are parallel, then the arcs that they cut are also parallel. So if this is 30 degrees, this is also going to be 30 degrees. Ah, nice, Becca. Okay. Very important, okay? This is one of the most important theorems. If two chords intersect in a circle, the product of the lengths of the segments of one chord equals to the product of the segments of the other chord. This is one chord, okay, A, B. Guess what? B times A should equal C times D. What do I mean by that? Easy. Let's say this is 10 and this is 4. CD, well, 4 times 10 is 40. Well, guess what? If A is 8, guess what the length of B should be? It should be 5, exactly, 5, because 8 times 5 is 40 and 10 times 4 is 40. So their product equals, okay, the product of the segments of one chord equals to the product of the segment of the other chord. Perfect. It says, the closer a chord is to the center of a circle, the longer the chord. Yes, yes, yes. And guess what? The longest chord is the diameter. Now look over here. This chord right here is not too close, as close to the center as it is chord CD. So that's why CD is longer than AB, chord AB. Oh, I get it, Becker. Yes, you get it. Okay. So, what else do you need to know? Let's talk about central angles. This is a central angle, right here. Because it comes from the center. Yes, I know. Wow, Becker really comes from the center. That's why it's called a central angle. Yeah. Well, the important thing, okay, the properties of this central angle are the following. It has the same measure as the arc it cuts, it intersects. Look. The arc here is 80, so then this angle is 80. Oh, because it's a central angle, so they have the same measure. Central angle is congruent to the arc it cuts, the measure. Let's talk about the inscribed angle. The inscribed angle is an angle that goes from the circle. Remember when we were doing inscribed circles, circumscribed? Well, this is an inscribed angle. Why? Because it is inside the circle. It is not a central angle. Okay, it is not a central. If it was a central angle, it would be like this, but it's not. And the measure here would be 100 if it was central. An inscribed angle, it's half the measure of the arc. So then if the arc is 100, then the angle is 50. See that? Cool, right? All right. Guess what? A circle, you could say, is a huge arc of 360 degrees. Okay? So for example, this arc is 100. So then the other part of the arc would be 260. So the whole thing could be 360. Cool, let's start doing the problems. All right, let's go on to the first problem. It says, in the diagram below, circle O has a radius 5 and CE is equal to. So right now CE equals 2. And the radius here is 5. Diameter AC is perpendicular to chord BD. Okay, so this is perpendicular to this chord. So how does that help me? Oh, it helps me in the fact that if the radius is perpendicular to the chord, it bisects the chord into two congruent segments. So this segment has the same length as this segment. BE and ED are congruent. All right. What else do I need to know? Well, I don't know. Look at the question. What is the length of BD? The length of BD. They want me to find the length of BD. This whole thing. Okay, fine, I'll find it. Not a problem. Now, when you deal with this type of chords and then perpendicular, radius perpendicular to something, it usually involves the use of the Pythagorean Theorem. Okay, but to use Pythagoras, I need at least two sides. Do we know what this OE is, the measure of OE? Of course, if the radius is 5 and the radius comes from the center, this is 5, this is also 5. And I got 2 here, so this is 3. All right. So now guess what? Now you have two sides of a right triangle. So now I can use Pythagoras Theorem. C squared equals to A squared plus B squared. And how am I going to apply this? Easy. Hold on. Let me make this larger. Okay, like that better. Well, let's take a look at this triangle right here, okay? So, I need to label it. I know that this is the hypotenuse, but how do I know this is the hypotenuse? The hypotenuse is always opposite to the right angle. Okay. So now, I need to label the other sides. This is going to be A, and this is going to be B. Or you could call this B and this A, really doesn't matter. The order doesn't matter, you're still gonna add them up. So, C squared, C is 5, so I'm gonna do 5 squared equals to A squared. What is A? A is 3 squared plus B squared. Okay. 5 squared is 25. Okay? 5 squared is 25. 3 squared is 9 plus B squared. I need to solve for B squared, so I'm going to subtract 9 from both sides. So B squared is equal to 16. Now what? At the end of every Pythagorean theorem, you will always have to take the square root of that. So let's take the square root of both of them. The square root of B squared is B. The square root of 16 is 4. Eureka! I found the value of B. So B here is 4. Cool then. So now I know what the length is. So would you say that we have found our answer by saying that B is 4? No. Look, this is 4 and this is 4. Remember that the radius is perpendicular, so it bisects the chord. So then into two congruent segments. So if this is 4, then this gotta be 4. So the whole thing is 8. So my answer is 8. Oh, cool, beker. Let's go on to the next problem. It says, in the diagram below of circle O, radius OC, okay, it is important always to take notes of everything that is unclear to you. And it is always very important as well to create the diagram. So OC is 5. Where is OC? OC is 5. This is OC. So this whole thing right here is 5. Okay, cool. What else? AB is 8 centimeters. AB is 8 centimeters and perpendicular to OC. So this AB is perpendicular to OC. And OC, as I can see, is actually a radius. Oh, and when a radius is perpendicular to a chord, it divides it into two congruent segments. Ha ha ha. And AB is 8. So then what is this PB right here? 4. And what is this AP right here? 4. And now what? Well, what is the length of OP? They want to know what the length of OP is. I know that the whole thing is 5 because that's what they said the radius was. But unfortunately, I don't have enough information to determine what is the length of each of the little segments. So what can I do? I know I have a right angle here. So therefore, something has to be a right triangle. Oh, wait, I got it. What if from the center, okay, a radius is a line segment that goes from the center of the circle to one of the endpoints, and the other endpoint is on the circle, like that. So if I draw another line segment like this from the center, would that be a radius? Of course. So this radius, what is the length of this radius? Well, all the radii in this circle are 5. Oh my God, guess what? I got two sides of a right triangle. What does that suggest? Pythagorean Theorem. So, Pythagoras Theorem. If you use Pythagoras Theorem, okay, so that is c squared equals to a squared plus b squared. We need to label which one is c and which one is a and which one is b. Easy. Opposite to the right angle is the hypotenuse. So this is c already. Oh, okay, so it's 5 squared. What else? Well, once you have your hypotenuse, it really doesn't matter which one is A and which one is B. So let's call this A. 4 is going to be A. And B, we're talking about this triangle, okay? So B, we don't know, so we're going to call it B squared. Or you could have called it X if you wanted to. Really doesn't matter. All right, so 5 squared is 25. So 25 equals 4 squared is 16 plus b squared. I'm solving for b squared, so what am I going to do? Subtract 16, so b squared is 9. Then I got to take the square root of that, and b becomes 3. So now, did I answer my question? I don't know. Let me see. They said, what is the length of OP? OP. Oh, I did. OP is 3, and therefore CP is 2. But the answer will be 3 because that's OP. Make sense? Cool. Let us go on to the next problem. All right, here. They're talking about triangle ABC, and they want to know which statement is true about this. Well, look at this. All of these are chords, okay? And they say, in the first choice, what they're telling you is the following. List the chords from largest to smallest. Look, AB is longer than AC, or greater. AC is greater or longer than BC. Okay, so from longest to shortest. So let's see. AB is longer than AC. AB longer than AC. The first fact that I have to keep in mind is that the closer a chord is to the center of the circle, the longer the chord is. So, how far is AB from the center? Is 2 units. How far is AC from the center? 4 units. So therefore, AB is longer than AC. Okay, so AB is longer than AC. It matches, it checks. Now, AC longer than BC. AC longer than BC. Well, how far is AC from the center? 4 units. How far is BC from the center? 6 units. So AC is in fact larger or longer than BC. So choice number 1 is your answer. Ah, nice. Let's try this one. In the diagram below of circle O, diameter AOB is perpendicular to chord. Again with the perpendicular. That means that it's going to bisect the chord. Okay. OA is 6. OA is 6. So right here is 6. Okay. What else? OE is 2. So that means that this is 4. I'm not sure if I need that piece of information, but that's what it says. Okay. What is the length of CE? They want to know what the length of CE is. Nah, that's easy. Everything is in relation to the radius, guys. Okay, you have to understand something. Once you know the length of the radius, you could do so much if you use your imagination. And if you use the fact that when they say perpendicular, it forms 90-degree angles, and therefore it's like calling your favorite friend, which is Pythagoras Theorem. Okay, so the length of CE. Anything that I draw from the center to an endpoint on the circle will be a radius. So let me draw it right here. Okay, so what is the length of this radius right here? Exactly, 6. Guess what? Now I got two sides of the right triangle, so now I can just use Pythagoras. A squared plus b squared equals c squared. So let's see now. C squared equals to a squared plus b squared. Not a problem. Now, what is the hypotenuse? Well, this is the right angle. So the hypotenuse is opposite to the right angle. So that's 6. So it's 6 squared equals, what is a squared? Well, this could be a squared. So that's 2 squared plus, and of course, b squared, which is the one that we don't know, which in this case would be this one. B squared. Okay, 6 squared is 36 equals to 2 squared is 4 plus b squared. What else? Nothing. Subtract 4 from both sides and you get 32 equal to b squared. You know that you cannot have b squared because that's not what they're asking you for. So we take the square root. So b equals to radical 32. Unfortunately, look at the choices. None of them is in radical 32. Oh, so I have to simplify. Okay, so let me divide 32 by all the perfect squares until I find the one that is the right one. So I divided 32 by 16 and I got 2. So that tells me that radical 16 times radical 2 is radical 32. Okay, now what is the square root of 16? 4 and radical 2. So there goes your answer. All right, let's continue with the next problem. All right, here we have the problem here. In circle O, okay, diameter dB. So this is a diameter right here. Therefore, remember, twice the radius is the diameter. All right. It's perpendicular to chord AC. So this is perpendicular to chord AC. We already know then that this divides the chord into two congruent parts. What else do I need? dB is 34. So all this dB is 34. Okay, what else? AC is 30. Cool. They want me to find the length of BE. Right here, BE. This length is what they want me to find. How am I gonna do that? I'm not sure. Let's see. If the diameter is 34, what I can conclude is that the radius, remember the radius is one of the most important artifacts or tools that you need in order to work with this type of chords. So if this is 34, that means that this is how much? The radius. The diameter is 34. How much is the radius? Right, 17. Aha, you got it. Okay. Now how is this gonna help me? Not sure. But one thing I know is the following. This diameter is perpendicular to this chord, and this chord is 30. So then this is 15, and this is also 15. Because once it's perpendicular, it bisects it, and that means that the two segments are congruent. Okay then. I got a right angle right here. What else do I need? Oh wait, Anywhere I draw a radius is going to have a length of what? 17. So let me draw a radius right here. Oh my God. So this radius is 17. Guess what? I got two sides of a right triangle. Now I can use Pythagoras. So let us use that. So I'm going to say the following. C squared equals to A squared plus B squared, right? Okay. Which one is the hypotenuse right now? Excellent. It's opposite to the right angle, so it's 17. So C squared is equal to A squared plus B squared. Like that. Okay, what is 17 squared? Well, 17 squared is 289. Excellent. Now equals 15 squared. What is 15 squared? 15 squared is 225, and of course we make it equal to, we add b squared. Alright, so now what we're going to do is we're going to subtract 225 from both sides of the equation. So let's do it. Alright, so you guys figured it out? Right, 289 take away 225 is 64. So that's what we're gonna have. So this is, I took away this, so I got 64 equal b squared. You know what's next, right? You know what we do at the end of every Pythagorean theorem. Right, we're gonna take the square root, so then the square root of 64 is 8. So, did I find my answer? Well, let's see. I found what OE was, which is 8 on this triangle. But they are asking me for the length of BE. Oh my God, you're right. So this, from here to here, that's the radius, right? 17. From here to here is also a radius. So what could be the length of BE? Exactly 9, because 8 plus 9 is 17. So boom, haha. You almost get tricked. No, don't get tricked at all. You know what you're doing. Cool, let's do the next problem. In the diagram of circle O below, chords A, B, and C, D are parallel. So these chords are parallel. Before even reading the question, what can you assume? Or what is true about this? Parallel chords cut congruent arcs. So if this arc is 60 degrees, this arc is 60 degrees. Oh my God, yo, Bexy, you're the best. Yes, I am. Okay. Now, the question is, if AD is 60, yes, we got that. What is the measure of CDB? What is the measure of angle CDB? CDB, this angle right here. Well, guess what? This is an inscribed angle. You see that? An inscribed angle. And what did we say about inscribed angles? That their measure is half of the arc they cut. So the measure is 30. Cool. Okay, let's go on to the next problem right here. In the diagram of circle, okay, so we have diameter. This is a diameter, is perpendicular. You know that what perpendicular means right here, that this chord gets bisected. Okay, so if AO is 10, AO is 10. I already know what the radius is. Keep that in mind, very important. And BE is 4. BE is 4. Okay, so what? Find the length of CE. They want me to find the length of CE. That's easy. Watch this. I'm going to draw a radius from the center of the circle. And you already know what this radius is 10, right? Cool. Now, do I know OE? Can you guys tell me what OE is? Exactly, it's 6. Why? Because if this whole thing is 10, because it's a radius, and we already got 4, then this is 6. Ah, come on. Now I got two sides of the triangle, of a right triangle. Now I know what to do. Cool. What is the hypotenuse? Well, the hypotenuse is opposite to the right angle. Oh, so 10 is the hypotenuse. Okay, so then let us start working with Pythagoras. So C squared is equal to A squared, in this case, 6 squared plus B squared. Then we have 100 equals to 36 plus b squared. Then we subtract 100 from both sides and we get b squared equals to 64. And then we take the square root of that and we end up with b equals 8. So this right here, my friends, is 8. Right? Now what did they want? CE? Oh well, we found it. CE is 8. And guess what? This is not a multiple choice question, so you just got 4 points on the regions. Ha ha ha. OD, right? All right. Here, it says, in the diagram of circle O below, chord CD is parallel to diameter AOB and measure of arc AC is 30. So if this AC is 30, okay, the question is, what is CD? Oh, I see. Measure of arc. You see this little symbol right here means denotes arc. Okay, it's bent. Oh, so they want me to find this arc right here. How in the world am I gonna find? How in the world am I gonna find the length of this arc right here? Well, this is what I know. I have parallel chords. Parallel chords cut congruent arcs. Am I correct?
Yes.
Yes, exactly. So then if this is 30, how much is this?
30.
30. Guess what? They say that there is a diameter here. So what does the diameter does to the circle? It cuts it what?
In half.
It cuts it in half. So therefore, how many degrees does a circle have?
360.
So half of 360 should be?
180.
So then this right here is 180. And how much do I have already?
30. 60.
Right, 30, 30 is 60. So there are 120 degrees flying around. Well, I already got this part, so this arc is 120 degrees. That's cool. So then the answer is choice number 2. See that? It's not difficult. Oh my God, we're almost done. All right, so let's see now. Let's do the other one. In the diagram below, let me just make this smaller. Oops, too small. Okay, let's see now. Yeah, that's better. Okay, in the diagram below, circle O, okay, chords are parallel. That's what it says. Which statement must be true? Okay, so let's take a look at the statements. Arc, you see now you know a new term. Arc CE is congruent to arc DF. CE is congruent to arc DF. What do you think? This is congruent to this because they're parallel? Of course. Parallel chords cut congruent arcs. You OD. All right, let's have the next question. In the diagram below of circle O, right, chord AB is parallel to chord GH. So these are parallel. Cool. Chord CD intersects AB at E. Wait, hold on a second. This is not so easy anymore. Chord CD intersects AB at E and GH at F. Okay. AB at E and GH at F. Okay. Question. Which statement must always be true? Oh, please don't OD with me. I know. Which statement must always be true? Arc AC is congruent to arc CB. Arc AC is congruent to arc CB. Not sure. Okay. Arc DH, where's DH? DH is congruent to arc BH. No, not really. Or maybe, I don't know, I'm not sure. AB is congruent to GH. Arc AB is congruent to arc GH. Do they look congruent to you? No. The last one. AG is congruent to BH. Oh my God. Whew, finally. Look, Parallel chords cut congruent arcs. Okay? Now that's what happens. Remember what it says. Chord AB is parallel to chord GH. This chord is parallel to this one. So therefore these two arcs are congruent. So the answer is choice number 4. Whew, I thought I was losing it. Alright. The next question. It says, in the diagram below, okay, guess what we have here? Parallel chords. So then the question is, which statement must be true? Well, take a look at it. Arc AC is congruent to arc BD? Yeah, so, wow, that was difficult. All right, let's try this one. Once again, you already know, okay? This is the topic we're discussing right now, so I don't need to tell you anything else. You read the problem right here, because you could just pause it and read it, okay? The question is this. If measure of CD is 70, CD, we're talking about not the chord, but look, the arc. See, you gotta be careful, gotta be observant of this. If arc CD is 70, okay, what is the measure of AC? They wanna know how much is this arc right here. Well, as my friend was telling me before, the whole circle is 360. Okay, parallel chords cut congruent arcs. So this arc must have the same measure as this arc. Not only that, if you read the problem, it says here diameter. Therefore, we have a diameter that goes through the center. What is the job of the diameter? To chop the circle in half. And once it does that, that means that right here on this upper half, I have 180 degrees. Guess what? I already have 70. So how much more do I need? 10. And these two arcs are congruent. So how many degrees is each arc? You are OD. Just in case you're trying to resist, okay? Good. Let's move on to our next problem. Here. It says, in the diagram below, trapezoid ABCD with bases AB and DC is inscribed in the circle. Okay. With diameter DC. The measure of arc AB is 80. Find the measure of BC. I should leave this up to you. And you know what? Yeah, I should, but I'm still gonna help you because sometimes you might need a helping hand. All right. What is this word right here? Diameter. Boom, diameter. What is the first thing that comes to mind? Half a circle. What comes to mind when you say half a circle? 180 degrees. Okay. What do you know about the isosceles trapezoid? Legs are congruent. This leg is actually the same as a chord. What do we know about congruent chords? They cut congruent. There you go, exactly, congruent arcs. So now I know that this arc AD is congruent to this arc BC. This is a diameter, so half a circle, 180 degrees. That means that there are 100 degrees flying around. Well, I gotta divide it between these two arcs. Okay. Difficult? No. Points? Yes. All right. Right here, let's see if you understood the concept. Let's see if you can make conclusions, draw conclusions from this. They want me to find the measure of arc AB. They want me to find the measure of this arc. Well, look at this chord. They say that they're parallel. Okay, these chords are parallel. So then what does that tell you? That they cut congruent arcs. So this arc and this arc are congruent? Yes. So therefore, 2x minus 20 equals x plus 20. And now find the value of x. Okay, I cannot have variables on both sides. So let me get rid of the lesser one. So I'm going to subtract x from both sides. 2x minus x is x minus 20 equal what on the other side? There you go. now I'm gonna add 20 to both sides and you get x equal 40. All right, so we found our answer. Have we? Find the measure of arc AB. That's why you always have to read the question. Find the measure of arc AB. I found x. So all I gotta do is go to AB and say, okay, so this is 20, which is the value of x. I'm sorry. Oh my God, I almost make a mistake. X is 40. So then it's 40 plus 20 is 60. So guess what? The measure of arc AB, so you do it like this. Measure of arc, like that, AB equals 60. And guess what? That's the end of lesson 28. I suggest you start reading lesson 29 so you are acquainted on how to do this. My God, it's a long lesson. Don't matter. All right, see you. Bye.